So today we would like to talk about why and when do we introduce the instrumental variables. So this happens when your independent variable x is endogenous. So for that, it means that the conditional expectation conditioning on your independent variable and the expectation of your error term is actually not zero. So this means that this conditional expectation is not zero. So for example, in the simple linear regression case, when yi equals to beta 0 plus beta 1 xi plus ui, then usually one of the assumptions for conducting OLS, ordinary least squares estimator, is that the conditional expectation of the error term on the independent variable x should be zero. But if this assumption is violated, then your OLS estimator is not going to be consistent. And I would also point out that when this conditional expectation equals to zero, it implies the covariance between x and u is zero, which means that the independent variable and the error term should be uncorrelated, right? But not necessarily vice versa. So the conditional expectation equals to zero is actually a stronger condition than the uncorrelation condition, right? So this situation is usually derived from several scenarios, such as one of them being omitting variables in your equation, and this happens usually in real life, right? Because it's very easy just to skip some of the variables to model, and then these omitted variables get absorbed in your error term. So in this case, what we can do is we can introduce another variable called the instrumental variable for x, right? And then we call it z. And for this z to qualify for being instrumental variables, it needs to satisfy two conditions. So one being the covariance of this new variable z and the old variable x, the covariance should not be zero, which means that these two variables, they should be correlated with each other. So z should be relevant with x, right? And another condition is to solve that endogenous problem, which is the covariance of this new variable and the error term and the original error term. This covariance should be zero. So which means that the new variable that you model and the error term, they should be uncorrelated. So this kind of helped to solve that endogenous problem. So for this, it just means that this new variable becomes exogenous, right? And actually, usually, we should also include the third condition. So for that, it should also include this condition called restricted exclusion. So for that, it means that exclusion, right? So for that, it just means that z, it should not directly affect y except through x, right? So we would actually talk about this a little bit later, and then I would also mention that actually here, right, when we see this error term, we know that we also have another thing called the residuals, right? So UI hat. Actually, UI hat is also a random variable, and this error variable u and ui, they're actually two different random variables, right? And because if you but then when you think back about the OLS, we know that this residual vector, right? This residual vector, it should all under OLS, it should always be perpendicular to the column space spanning the design matrix X, which means that this residual vector, it should be orthogonal to every single vector in that column space of design matrix X. For that, it being that, this residual vector is just going to be perpendicular to all the X vectors, right? Okay, so but then we would actually talk about like how this residual vector and this error term, how they differ, right? Like in terms of their sample covariance and so forth a little bit later. And then after singling that out, we would also like to mention that, so therefore we cannot directly estimate this original beta 1, right? Because it's gonna be not consistent, so therefore it's not gonna be a viable estimator, right, under OLS directly to estimate beta 1. So therefore, after we introduce this new instrumental variable z, we actually introduce a new parameter, new estimator called the IV parameter, right? And then this is its formula, and then we're gonna show later that this new IV estimator is actually consistent, right, to the true parameter beta 1. So therefore, even though it's not biased, but at least it's consistent, right? So therefore, it can be a viable estimator for beta 1 instead of directly estimating this beta 1 under just direct OLS. And we're also going to derive why the estimator of IV appears to be with this formula. Okay, see you soon.